is if I add data to the bottom of this table, our chart should update automatically. So let's once again try copying in the data from our second worksheet and then pasting it directly beneath our data set that our chart's currently referring to. So now, drum roll please, if we scroll back up, look at this. Our chart has automatically incorporated all of the new data automatically. You can see that our date range on our category axis now ranges from January 1st all the way to the end of February. And obviously we could continue this process of adding more data to our chart data range as much as we wanted, and we would never have to actually change the underlying chart. We would never have to repoint our data series to new ranges of cells, because as long as the name of our table and the names of the columns within our table are consistent, every time we add data to that table, our chart will automatically pick it up. But back to our main sample data set. Now that we have all of our derived columns in order, we're ready to start doing something truly useful with this data. And Excel actually has an extraordinarily powerful tool for summarizing and analyzing large data sets like this one, and that is pivot tables. We'll start our exploration of those in the next video. I'll see you then. Welcome back. As we've seen over the last few videos, structuring data as Excel tables gives us a whole host of advantages compared to plain old rows and columns. Tables make data entry and management, and even writing formulas, way easier and less error-prone. And in so doing, they can make your spreadsheets more robust and maintainable. With that in mind, let's try our hand at enhancing our budget and expense tracker with Excel tables. Now, the first and most obvious place to start is to convert any list-like data structures in our workbook to tables, and then adjust any formulas pointing to those tables accordingly. Now, this would include our list of monthly income sources, as you see here, then our list of monthly expenses, as you see here, and also our transaction history that we get from our bank's website. Now note that we have a couple formulas on our summary worksheet that refer to our expense and income lists, right here in cells C3 and C5. Make sure you update those formulas to take advantage of dynamic table references that always encompass exactly the data in the table, nothing more and nothing less. Now we'll need to do the same with our formulas that crunch out total expenses by category on the hidden spending summary worksheet, since that data from our transaction history worksheet will now be stored in a table as well. Now this is all pretty straightforward, but there's one more application of tables I'd like for you to incorporate. What I'd like you to do is create another higher level of categorization to apply to our expenses, as you see here in column E with the category group column. In other words, instead of just breaking our transactions down into 16 categories like we are currently, we'll add a new level of grouping that breaks them into a much smaller number of higher level categories. Now you've been provided with this little mapping here of our current categories to these higher level groups. So what I'd like you to do is create a lookup table with this mapping on a new worksheet in our budget and expense tracker project, and then use that mapping to VLOOKUP in the new grouping to our transaction history data. Not only will this keep us from writing a gnarly nested if function to accomplish the same thing, it also makes maintaining and updating the list a breeze. Just change the mapping and all of our formulas will adjust automatically. So at this point, go ahead and pause the video and try to implement these changes to your budget and expense tracker workbook. Then whenever you're ready, hit play to see how I did it. Okay, so hopefully that went well. So now I'll go back to our starter file and walk through the steps to get this done. So first I'll go to my list of monthly income sources, and I'll just hit Control-T with my cursor anywhere inside that data, and I'll make sure that the My Table Has Headers option is checked, and then click OK. And then I'll rename our table to Income. And now similarly, I'll convert our list of monthly expenses to a table as well. And again, the same steps, Control-T to automatically convert this list to a table, We click OK. And then I'll rename this table to expenses. And now that I've converted both of these lists to tables, I'll go back to my summary worksheet and adjust our formulas that reference those lists accordingly. So first in cell C3, where I have my total monthly income, instead of summing the entire column from the monthly income worksheet, I'll just sum the appropriate column from our table. So I'll go to my monthly income worksheet and then just highlight the values in the estimated amount column. And now you can see that my formula has changed to, instead of using cell references, to just reference that column from the table. So I'll close my parenthesis, hit enter, and we have the same number. And then I'll follow the same steps for my total monthly expenses. So I'll get rid of the references that are already in the formula. I'll go to my monthly expenses worksheet, highlight just the values in the estimated amount column, close the parenthesis, and now that's working as well. Next, I'll follow similar steps to convert my transaction history data to a table. So again, Control T, and then OK. And I'll name this table Transactions. And then I'll unhide our spending summary worksheet, which we're using as the basis for our bar chart. And while I'm at it, I'm actually going to change the name of this worksheet from spending summary to chart data, which is a step I had suggested previously, since that's what we're using it for now. But now going into our first SUMIFS formula, we see that we're referring to entire columns on our transaction history worksheet. But now we just need to refer to columns in that table. So in place of the entire column D, let's just delete that, and then go to our transaction history worksheet, and then just select all the values in our debit column by selecting the first cell in that column that contains data, and then hitting Control-Shift-Down to select just the data in the table. And again, you can see the reference changes from being cell references to just looking at that column in the table. And then we'll do something very similar for our column C here. So now we'll scroll up to the top, select that first value in the column, and then Control-Shift-Down to select all the values. And then I'll add our comma back in to separate this from the last argument of our SUMIFS. And at this point, I think it should be working. So let's hit enter. And it looks like that's the same number as before. So now we'll just double click to fill down. And just clicking through the formulas, it looks like they're all working just like before, except we're now referencing all the values in a column in the table only and not the entire worksheet. So now I'm good to go ahead and hide this worksheet again. And now our next phase will be to bring in that mapping between purchase categories and broader category groups from the other worksheet. So first I'll create a new worksheet that I'll call Lookup Table to accommodate that data. And then I'll go to our worksheet that has that mapping called Categories, and then I'll select it, copy it, and bring it back into our file, and paste it. And then of course I'll convert this to a table, and make sure to specify that my data does have headers. And I'll call this table Categories, and auto-fit our column widths. And now that we've got our lookup table in place, it should be easy to bring in these new, broader category groups into our transaction history data. So let's select our transaction history worksheet, and then scroll up to the top, and add a new column called Category Group. And we'll auto-fit that, and then in this column, we'll write a VLOOKUP. And then our lookup value will just be whatever value in the category column is in the same row as the current VLOOKUP formula. So I'll just select cell C2 here, and then a comma. And then our table array will just be the values from our new lookup table. So I'll select that worksheet and highlight all those values. And again, because we're working with tables and not just ordinary ranges, you don't see the range A2 through B17 selected. You just see the name of our table, which is categories. So of course this means if we were to decide to expand our mapping here by adding more rows, we wouldn't need to change any of our formulas, because those new rows would still be part of that categories table. So now we'll add another comma, and then a 2, because we're looking 2 columns over, and we do want an exact match. So now we'll close our parenthesis and click OK. And because we're working with table formulas, the formula auto-populated for the entire column in the table, and it looks like it's working just fine. Okay, so now that we've got all of our lists of data in our budget and expense tracker workbook converted to tables, in the next section, we'll learn how to create powerful summary reports from this kind of data. And then after that section, we'll apply what we've learned once again to our project. I'll see you in the next video. Hey, welcome back. It's time to begin our exploration of maybe the single most powerful feature in Excel's arsenal, pivot tables. So what the heck is a pivot table? In short, it's a tool for rapidly summarizing and analyzing data, with no formulas required. Pivot tables especially shine when it comes to quickly gleaning insights from large data sets, those with far more distinct records or data points than we could possibly reason about without some help from Excel's massive computer brain. But there's a kicker. Pivot tables are picky about how your data is structured. If you want to analyze a data set with pivot tables, it must be organized in a tabular fashion. That is to say, with columns containing distinct types of data and column headers describing those columns. This is a small price to pay, though, and honestly, that's how you should be organizing your data 99% of the time anyway. Now, I could keep going on and on about how awesome pivot tables are, but they're really more of a show kind of feature versus a tell kind of feature. So let's go ahead and get some hands-on practice using pivot tables. So here we have our sample call center data set that has a variety of statistics pertaining to calls received at a call center. It also contains a number of categorical or non-numeric fields that describe or categorize each data point in a certain way. For example, in column J, the employee name, which is the name of the employee who took the call, the site where that employee works, the manager of the employee, and the type of call that was taken. Applying a pivot table to this data set will allow us to combine quantitative metrics like call duration in minutes and abandoned calls with categorical fields like employee name and site in ways that will give us quick insights into this very large data set, which ranges almost to 100,000 records. So how do we create the pivot table? Well, there are a couple ways we can go about it, but my preference is first to select the data set that we're going to analyze with our pivot table, and then insert the pivot table once the data is selected. Now note here that it is crucial to include the column headers in the data you're selecting. Every aspect of the process of analyzing data with a pivot table will revolve around the concept of our data being organized into columns. So having column headers and descriptive names in those column headers is key. So with that said, let me go ahead and select our entire data set, which I'll do using Control-Shift right arrow, Control-Shift down arrow. And now to insert the pivot table, I'll go to the Insert tab on the ribbon, and then click the Pivot Table button all the way over on the left. And now you see in this dialog box that Excel recognizes that we've already selected the range of cells that we want to analyze with the pivot table. And you can also see that using an external data source is an option, and that's something we'll look at a little bit later. Now, the second choice that Excel presents us with is where we want our pivot table report to be placed, in a new worksheet or the existing worksheet. Most of the time, you're going to want to place your pivot table in a brand new worksheet because the data you're analyzing is taking up so much space on the other worksheet, it really wouldn't make sense for you to try to put both in one place. So we'll leave the default of new worksheet and then click OK. And over here on the right, you see what we can think of as the command center for our pivot table. First, there's a list of all the fields in our data, which Excel was able to recognize because we organized our data into columns and named those columns with column headers. And then down below that list of fields, we see 4 empty squares. One for filters, one for columns, one for rows, and one for values. And Excel is telling us that we can drag fields between those areas. So I'm not going to explain what all 4 of these areas are for right away. Instead, I think it's more constructive to just go ahead and drag one of our fields into one of those areas so you can see how it works. So I think I'll grab my site field and I'll drag it into the rows area at the bottom left. And now what we see is that a list of the unique values in our site column, which is to say our 3 sites, has been inserted into our blank worksheet. So by itself, that doesn't seem terribly useful. I mean, couldn't we have gotten a list of distinct values just by using the remove duplicates feature, for example? Well, yes, but this is a crucial first step to data analysis because typically your analysis is going to involve breaking down your data set into different categories and then comparing summary metrics among those categories. And in order to compare categories, we first need a unique list of those categories. If we want to compare our 3 sites, we first have to have just those 3 sites listed side by side. So the key thing to remember is, whenever you drag a field from our data into either the rows area or, and I'm getting ahead of myself here just slightly, the columns area, Excel will automatically display just the unique values from that column, no matter how many records the dataset has. So now is where we can actually begin our analysis. So let's say we want to know how many calls were taken at each of our sites. So what we'll do is drag, say, the call ID field into the values area. And keep in mind that by drag, I mean that I'm hovering over that field in the fields list, clicking and holding my mouse button, and then dragging down to that values area. So now I hope that you're getting the gist of how this works. Excel is attempting to apply a summary calculation of the values in our call ID field broken out by the unique values in the site field. The only problem here is the calculation Excel applied by default just doesn't make a lot of sense. If we go back to our raw data worksheet, we see that while call ID is a number, it's not really something that makes sense to try to aggregate statistically. Call IDs are just that. They're unique identifiers. They're not meant to be summed or averaged. What we really want to do here is just count the call IDs, so that no more weight is assigned to the 50,000th call ID than to the first. So let's go back to our pivot table, and then click this arrow to the right of call ID in our values area. And then we'll choose Value Field Settings. And right away you can see the problem. Excel guessed that we wanted to sum the values in that field because they were numeric. It just wasn't smart enough to recognize that while those fields were numbers, it really wasn't meaningful to try to add them. So instead we're going to choose Count, and then click OK. And there we have it, a breakout of the number of calls taken by each site. Now, I wouldn't blame you for thinking this all looks a little magical and being a little skeptical about the accuracy of these numbers. So let me prove it to you. Let's take note of the number of calls at the Jacksonville, Florida site, 35,562. Now let's go back to our data worksheet and apply filters to our data set. And now I will filter for just our Jacksonville site. And if you look down to our status bar at the bottom left, it says 35,562 records found. So I hope at this point you'll believe that the other 2 numbers are accurate as well. Now, if you want to see the detailed data behind any of these numbers in the pivot table, you don't have to go to the trouble of filtering the source data set. Instead, you can use Pivot Table's drill down feature to get to that detailed data in literally 2 clicks of your mouse. So if I just double click this number here associated with the Jacksonville, Florida site, Excel automatically generates a table with just those records pertaining to that particular group. And if we click the filter button on the site column, you'll see that the only site in this data set that was generated is Jacksonville, Florida. And then if I click in my first row of data and then Control-Shift down arrow to select all the way to the bottom, you'll see in our status bar we have a count of 35,562 records, once again proving that Excel only included records pertaining to that particular site in our generated data set here. So I'll go ahead and delete this sheet that was generated. And now lastly, I'll show that you are not limited to adding just one metric to your pivot table. Let's say we want to break out a couple other summary statistics by site. For example, maybe we want to see a count of abandoned calls by site. So if I scroll down to find call abandoned among our pivot table fields, and then just drag that down to the values section, we'll see that not only does the metric slot in neatly next to our previous one, but this time Excel's guess that we wanted to apply a sum calculation to the values does make sense. If we go back to the call abandoned field in our source data, you can see that every record has a value of 1 or 0, with 1 indicating that a call was abandoned and 0 indicating that it was not. So by simply summing all of the 1s, we effectively get a count of all the abandoned calls for that particular site. Just to reiterate, and again using the Jacksonville, Florida site as an example, Excel is basically saying, first, let's only consider records in our source data set where the site is equal to Jacksonville. And then for our first metric, let's count those records. And then for our second metric, let's sum all the values in that call abandoned field. So if I were to again go back to my data set, and with a filter of Jacksonville, Florida already applied to my site column, if I then apply a filter of 1 to my call abandoned column, Excel tells me that 2,154 records were found. And if I navigate back to my pivot table, that's exactly the number we see for our sum of call abandoned metric. So while we're at it, I'll throw in one more metric, which I think will be call duration in minutes. Now in this case, a simple sum of all the minutes that all the agents at each of our sites spent on the phone isn't that interesting. What I would instead like is an average of how long those calls took. So I again need to change the default calculation that Excel chose for this metric. So let me scroll down to the values section until I see our sum of call duration, and then click our little arrow, and then go to Value Field Settings. And now I'll change the type of calculation applied to this field to average, and then click OK. And now we can see that the employees at our various sites are fairly consistent in terms of how long they take to finish a call. It's roughly 12 minutes per site. So before we go, let's just reiterate the basic structure for our pivot table here. Categorical data, typically non-numeric things like the names of call center sites or employee names, will usually go into the rows or columns area of our pivot table. Then, numeric values to which we can apply statistical calculations typically go in our values section. And then those fields will be summarized statistically by the unique values in whatever columns we dragged into our rows or columns area. And then lastly, I'll point out that there's this weird pseudo column that has appeared in our columns area. So this values pseudo column basically just means that our summarized values are appearing as columns in our pivot table. The count of calls is in the first column, the average of call duration is in the second column, and the sum of abandoned calls is in the third column. Okay, so we've already done a lot with pivot tables, but there is so much more that we can do. We've really just scratched the surface. Up next, we'll look at how we can add even more layers to our pivot table analysis. I'll see you then. Welcome back. Thus far, we've seen how we can use pivot tables to break down summary statistics about our data, number of calls, total abandoned calls, and average call duration by a single dimension, the site where the calls were taken. But what if we wanted to slice and dice our data in more ways than one? Fortunately, pivot tables make this kind of multi-layered analysis intuitive and fast. Let's see how this works by building on our example from the last video. First, by way of briefly recapping Pivot Tables 101, I'll recreate that pivot table from the previous video, but this time from an Excel table instead of a range. So here we have the same data set as in the last video, but it's been converted to an Excel table called call data. So it turns out that this makes the process of creating a pivot table, but also keeping that pivot table source data up to date a lot easier than simply creating a pivot table from a range. So as long as I have any cell within this table selected, if I just go to Insert and then Pivot Table, Excel correctly guesses that I want to use this table, which I've named Call Data, as the source of my pivot. So I don't have to worry about highlighting any cells. Merely having one of those cells inside the table selected is enough. And just like in the last video, I'll choose New Worksheet and then click OK. And now we're back to our familiar pivot table command center. Now before I start dragging and dropping fields to recreate our pivot table, I want to again emphasize the advantage of creating a pivot table from an Excel table versus a range. Not only did it make it easier for me to create this pivot table, but as I add more data to that table, my pivot table will pick up on those changes automatically, versus me having to reselect a larger range every time more data is added. Alright, so to recreate our pivot from the last video, I'll first drag Site under my Rows area, and then Call ID in Values, and then I'll convert that calculation to be a count, and then Call Duration, which I will convert to be an average instead of a sum, and finally Calls Abandoned, which I will leave as the default sum. But the real point of this video is going to be to add more layers to our analysis. So in the spirit of showing more than telling, which is generally conducive to the learning process when explaining pivot tables, I'm just going to drag another field into our rows area. And that will be employee name. So I'll drag that under our site heading. And now we see that under each site heading, we have a list of all of the employees who work at that site with their individual statistics broken out. And then on the rows where the actual name of the site is listed, the summary statistics for that site overall are listed. Now I'll add another layer to this by dropping in manager name below site but above employee name in our rows area. And now if I scroll up, you'll see that we have yet another layer in our hierarchy. Under our Aurora, Colorado site, we see the next level in the hierarchy down is the names of our managers. And then below each of those managers, we have the names of all of their employees. And at each level of the pivot table, whether it be site, manager, or employee, we see the statistics specific to that particular level to the right of that entity in the rows area. So a couple things I want to clarify before we move on. One is that you can think of each number in the pivot table as a kind of intersection or address of any number of filters that are being applied in the rows area or the columns area of the pivot table. So if I look at this number 89 here in cell C7, that number represents the sum of abandoned calls at the intersection of our Aurora, Colorado site, a manager named Elsie Taplin, and an employee named Aleda Singh. So that metric is being calculated only for rows in our data where all three of those conditions are true. Where our site is Aurora, Colorado, our manager is Elsie Taplin, and our employee is Aleda Singh. Likewise, if we move up to cell C5, this number 643 represents all the abandoned calls where the manager was Elsie Taplin and the site was Aurora, Colorado, but because we're only at the second level of the pivot table hierarchy and not the third, no employee level filters are being applied to that number. And lastly, this 1,981 here just represents all the abandoned calls at the Aurora, Colorado site. Now the other point I want to make is in regards to your decision as to how to order your fields in the rows area of the pivot table fields list. So your general rule should be fields with fewer distinct values, like for example site, should go highest in the hierarchy, and fields with more distinct values should go lowest. Take for example what would happen if I moved employee name to the very top of our list of fields in our rows area. So if I click this arrow next to employee name, and then choose Move to Beginning, our pivot table still produces accurate numbers, but these hierarchies are no longer meaningful. Instead of a larger site level number being broken out by smaller subtotals, those being for manager and employee, we instead start with the smallest subtotal. So our total for our first employee here listed, and then the subtotal for the site, and then the further subtotal for employee are all the same number. So again, you want to think of this as a hierarchy where the field with the fewest distinct values goes first, and so on. So I'll move employee back to the bottom of the hierarchy by clicking our arrow here and choosing Move to End. And now lastly, just to demonstrate that you can have fields in the columns area as well as the rows area in the same pivot table, I'm going to drag our call type description field into the columns area. And now just to make a little bit more room, I'm going to close out of our pivot table fields list here. And while you could correctly argue that this pivot table is getting a little busy, it's still providing us a pretty powerful and condensed summary of a reasonably large amount of data that we have on our data worksheet. So moving horizontally across the top of the pivot, we see that we have 3 primary columns, one for each call type description, billing, sales, and tech support. And then under each of those primary columns, we have 3 secondary columns for each of our metrics. So basically these metrics are subheadings under each of the primary headings that are our call type descriptions. And just to extend the analogy that we used earlier about each of these numbers representing a kind of intersection or address among all the different fields that have been dragged into the row area or column area, if we look at this number 28 here in cell C12, this represents the number of abandoned calls that had a call type description of billing that were taken at the Aurora, Colorado site, that were taken by an employee whose manager was Elsie Taplin, and that were taken by the employee whose name was Sheila Garcia. Now just to confirm that, let me go back to my data worksheet, and I'll first filter for site equals Aurora, Colorado, and then I'll look at my manager name field and look for our manager, so we're filtering for Elsie Taplin, and then I'll look for our employee in the employee name field, and that was Sheila Garcia, and lastly I'll filter for call type description equals billing, and then I'll filter for call abandoned equals 1, which should give us our count of abandoned calls. And we'll see if we apply all those filters that 28 records were returned, which is, of course, the number reflected in our pivot table for the intersection of all those distinct values. Now, before we move on, I want to demonstrate a technique you can apply to condense the output of pivot tables as they can grow somewhat more elaborate like the one we see here. So looking at our row headings, you'll see that there are these little minus signs next to the top 2 levels among our fields in our rows area. So if I click this minus sign next to Elsie Taplin, suddenly all the detail data underneath her disappears. And then if I click the plus sign next to her, it reappears. Now you can also do this at the site level, so I can click this minus sign next to Aurora, Colorado, and then all the data under that collapses. And then I can again get it back just by clicking the plus sign. Obviously this isn't applicable to the headings at the lowest level of the hierarchy, that being employee. Now if you want to collapse a certain level of the hierarchy for the entire pivot table and not just a single section, you can actually right-click any entity at that level of the hierarchy and then hover over Expand and Collapse and then choose Collapse Entire Field. And now for our entire pivot table, the detail has been collapsed to the level of site and manager with individual employees no longer being visible. But then if I right-click any of these managers and then hover over Expand and Collapse and then choose Expand Entire Field, now all of our employees are visible yet again. Now before we move on, let's swap out the row labels on our pivot table with something perhaps a little more interesting, a date. But first we need to get our pivot table field list back. So how do we do that? Well, you might have noticed at the top right corner of our ribbon that we have this new contextual ribbon tab, just like we see when we click inside of an Excel table. And that, of course, is because we have clicked inside of this pivot table. So if we click this Pivot Table Analyze tab, we'll see that we have a whole set of controls specific to pivot tables. Now, the one we need to show our field list again is this Field List button at the very top right. If we click that, our field list reappears. So our goal here is to remove Site, Manager, and Employee from our rows area and replace that with our Call Timestamp field, which lists the date and time on which a call was placed. So to remove fields from the pivot table, you don't even have to click in the rows area or the columns area. Instead, you can simply uncheck them from the fields list here. So I can scroll down and uncheck employee name, uncheck site, and uncheck manager name. Now this is a fairly uninteresting pivot at this point, but all we have to do to fix that is just drag in call timestamp to our rows area. And right away we see something interesting. Even though our call timestamp field simply had date time values, Excel has automatically grouped these values by month. And then if we click this now familiar plus sign under May, we'll see that our May calls have been broken out by individual date. So Excel clearly has some built-in intelligence around how to handle date and time values in a pivot table. But we don't have to depend on Excel's artificial intelligence to decide how to group date values. So let's say I decided I didn't want months to be included in my pivot. I certainly didn't explicitly ask for that. Excel just assumed that I wanted it. How would I remove that? Before I make that tweak, I'm actually going to change the layout of our pivot table field list over here to make it a little easier to work with when we're focusing on the rows, columns, and values areas. So I'll click the arrow next to this little gear icon, and then choose Areas Section Only 2x2. And now I have a much clearer view of the fields in the different areas of my pivot. So you'll see that Excel has automatically added this months pseudo field above my call timestamp field in the rows area. But I can click the arrow next to that and choose Remove Field. And now my data is broken out just by date. But what if I wanted to add some other sort of date grouping? Maybe I wanted my data to be broken out by year, month, and date. To do that, I would simply right-click any of the date values in my row labels, and then choose Group. And you'll see that by default, Excel assumes, and this is the assumption we saw it make earlier, that we want to group by days and months. But clearly we have a lot of other options here. We can also group by years if we want, quarters, or even hours, minutes, and seconds. So I'm actually going to uncheck years, but then select hours. So now we should see our data broken out by month, day, and even hour of the day. So now I'll click OK. And now instead of just seeing patterns in how our calls arrive on days of the month, we also can see hourly level trends, which is a whole new level of analysis. So lastly, before we go, I'll just change my pivot table field list layout to its default. So I'll click again this gear icon and then choose Field Section and Areas Section Stacked. Now speaking of layout and appearances, we haven't been paying much attention to the aesthetic appeal of our pivot table. Up to this point, we've focused strictly on number crunching. But up next, we'll explore some of the ways that you can customize the format, look, and feel of your pivot tables. I'll see you then. Hey, welcome back. So up to this point, we've learned to leverage pivot tables as a very powerful tool to analyze large amounts of data quickly. But providing truly effective data analysis is more than just about crunching numbers. It's also about presenting your data in a way that is easily understandable and attractively formatted to a broad audience. So in this one, we're going to clean up our example pivot table here to make it something we wouldn't be ashamed to present to the CEO. So my first step here is actually going to be to remove call type description from my columns area. While that is a useful breakout to have, as you'll see later, it's perfectly possible to have more than one pivot table pointing to the same data set. And when you find that you've dragged so many fields into your pivot table that it's hard to reason about what each number in an individual cell means, it's probably time to start removing fields. So I'll go to my field list and then remove my call type description field. And now I think I'll actually replace my dates in my row area with our original hierarchy of site, manager, and employee. So I'll remove my months field, my days field, and my call timestamp field. And then I'll add back in my site field, my manager name field, and finally my employee name field. So now instead of a pivot table that's kind of trying to be all things to all audiences, we have a clean, focused breakout of 3 primary statistics by an employee hierarchy that goes from manager all the way to site. So the first step in our visual cleanup here will be to properly name and format our metrics in columns B through D. For example, this column name count of call ID isn't exactly descriptive and doesn't really tell an end user of our pivot table what the numbers in that column really mean. And furthermore, considering the numbers in this column typically are so large, it would be nice to format them with a comma in the thousands place. So how do we go about doing that? Well, first I'll tweak the layout of my pivot table field list to only show the areas section 2 by 2. So now we've got a cleaner view of all the fields we've dragged into our pivot. And then I'll click the arrow to the right of my count of call ID metric, and then choose Value Field Settings. Now here, in the Custom Name dialog box, I have the option to type in, as you might guess, a custom name for this field. So I think I'll call it Calls Received. Now as to adding the comma in the thousands place of the numbers, all I have to do is click this Number Format button in the bottom left corner of the dialog box, and then I can format those numbers the way I would format any other number in an Excel spreadsheet. This Format Cells dialog box should look pretty familiar to you. So I'll go to Number, and then because our number in this column is a count, I won't need any decimal places, so I'll place a 0 there, and then I'll put a check mark next to Use Thousands Separator, and then click OK, and then OK once again. And now we have a meaningful name for our column that contains data about the number of calls our site's received. And these numbers have been formatted with a comma in the thousands place. So now let's take some similar steps to clean up our Sum of Call Abandoned field. So again, I'll click that field in my pivot table field list, choose Value Field Settings, and then I'll assign a custom name of Calls Abandoned. And again, I'll format this number to have a comma in the thousands place with no decimal places. And then lastly, for my average of call duration field, I'll format that to have 1 decimal place, since this is a number that potentially could be fractional. So again, clicking that in the fields list, I'll change the name to average call duration, and then format the number to have 1 digit after the decimal place. And I think you can agree we're looking way better already. But there's a lot more to formatting pivot tables than just formatting the numbers in our metrics. So if we click this Design Contextual tab in the ribbon, on the right we'll see a number of built-in pivot table styles, very similar to the styles that we were able to apply to Excel tables. So if I click the down arrow to the right of these, I can hover over any of these for a preview of how our pivot table would look with that given style applied. Now my personal preference has always been the light blue pivot style medium, so I'll go ahead and click that one. Obviously, your taste or the taste of your audience may differ, but that's why Excel has so many built-in formatting options available. Now another visual feature of our pivot table to consider is its layout. So over on the left side of this Design tab, we'll see a button called Report Layout. Now if I click that, I'll see that we actually have a few different layout options. There's Compact Form, Outline Form, and Tabular Form. Now the current and default layout, which is the one I would recommend for most cases, is Compact Form. So if we select that, nothing changes. But if we change our layout to Outline Form, you'll see that now each of our fields that we dragged into the rows area of our pivot table field list, basically our row groupings, gets its own column. So Site is now in column A, Manager Name is now in column B, and Employee Name is in column C. This can be a helpful layout if you really want to emphasize the levels of hierarchy in your pivot table and how the different fields in the rows area relate to each other. Then the tabular form is really very similar to the outline form. It just gives you a little less breathing room visually. This is one that I personally wouldn't recommend, since the outline form is so similar, but provides a little more breathing room visually. But again, in the vast majority of cases, the default compact layout is perfectly sufficient, so we'll go ahead and revert to that. Another important visual aspect of pivot tables is subtotals. These are the aggregations of our metrics that we see at each level of the hierarchy in our pivot. For example, we see manager level roll-ups of our 3 metrics for each manager in our pivot table in the row in which that manager appears. This 10,872 number to the right of Elsie Taplin represents the total number of calls received by Elsie's employees. Likewise, we also have subtotals at the highest level of hierarchy in our pivot, which is site. Hence why we also see these even larger numbers in the same row as our Aurora, Colorado row header. Now these subtotals will appear in your pivot table by default, and most of the time you'll want to keep them. They're very useful, and typically people want to see how these metrics break down at each level of hierarchy in your pivot table. However, you do have the option to manipulate whether or not they appear and where they appear. So if we click this Subtotals button on the left side of the Design tab, we'll see that we can opt to not show subtotals, in which case all of those roll-ups at each level of the hierarchy disappear. In this case, after choosing this option, we only see our metrics for the lowest level in our hierarchy, which is employee. Again, most of the time not what you're going to want, but it's worth noting that that is an option you have in case, for whatever reason, your audience finds the subtotals to introduce too much clutter into your pivot tables. But for our purposes, I'm going to add our subtotals back, and I'll make sure to do it at the top of the group, because while you do have the option to add them to the bottom of the group, it's just not as aesthetically pleasing and will be confusing to most users of a pivot table. So not only does our pivot table have subtotals by default that break down our metrics for each level of hierarchy in the pivot table, it also has grand totals that display all-in numbers for our metrics calculated across all the rows in our source data. So to see these, first I'll collapse our site level groupings by right-clicking our Aurora, Colorado site, and then hovering over Expand and Collapse, and then clicking Collapse Entire Field. And now if you look at the bottom of our newly condensed pivot table, you see that there is a grand total row that adds up our 3 metrics for all the rows in our source data set. Again, like with our subtotals, you'll want to keep grand totals in your pivot tables most of the time. Most users would be interested in comparing the numbers at each level of our hierarchy with the all-in number at the very bottom. However, just like with subtotals, Excel does give us the option to switch these grand totals on and off for all the positions they can occupy in the pivot. So if we hit this Grand Totals button on our Design tab, you'll see that we can turn grand totals off for rows and columns, on for rows and columns, on for rows only, and on for columns only. Now because our metrics are oriented by columns, it really only makes sense for our grand totals to be on for columns. But because our metrics are oriented that way, it really doesn't matter if we choose on for columns only or on for rows and columns. So if I remove our grand totals by choosing off for rows and columns, and then go back to my grand totals button and choose on for columns only, we see our pivot table looks just like it did before. And then if I turn our grand totals off again, and then choose on for rows and columns, it's the same layout as before, because again, our metrics are oriented by columns and not by rows. Alright, so we've got our pivot table looking sharp, but there's still a lot more to learn about pivot tables. Up next, we'll look at how you can add filtering to pivot tables to give you even more dimensions by which to slice and dice your data. I'll see you then. Welcome back. Up to this point, our pivot tables have been static, which is another way of saying that other than expanding or collapsing groupings, there hasn't been any real mechanism for an end user to slice, dice, and otherwise interact with the output. But we're about to change that by adding filters to our pivot table. Filters on pivot tables work in much the same way as filters applied to ranges or Excel tables. They allow us to narrow the scope of the data we see in the pivot to zoom in on some subset of the data that we're interested in. Filtering can be applied at the report level or to individual fields within our pivot. Report level filters are what will really empower our end users to create custom cuts of the data, but we'll start with filters applied to individual fields to get us warmed up. So here in our example pivot table, let's say I wanted to filter our output to only show data pertaining to our Jacksonville, Florida site. So to do that, I need to click any row header that's at the same level of hierarchy as the Jacksonville, Florida site, which of course is the site level. So for example, I can just click my Aurora, Colorado row header here, and now I'll be able to apply filtering to that level of the hierarchy. So having selected that cell, I'll then click this filter button in the top left cell of the pivot, and now we have a filtering dialog box that's pretty much the same as the ones we've seen for Excel tables and just applying filters to ranges. So now I'll uncheck Select All, and then check Jacksonville, Florida, and click OK. And now the scope of our pivot has been narrowed to just data pertaining to our Jacksonville, Florida site. So what happens if I want to apply filtering to a different level of our hierarchy? For example, maybe I want to filter my output to focus on a handful of managers versus seeing all of them, but I'm not interested in applying a site level filter. Well, first I'll clear our existing filter, and then to apply a filter to the manager level of our hierarchy, I'll just click any of the row headers that contain a manager. So for example, I'll click the cell that contains the row header for Nova Harshberger. And now if I go back up to my filter button, you'll see that instead of our sites being listed, all of our managers are listed, because the cell I had selected before clicking the filter button was at the manager level of the hierarchy. So now I can just randomly select a few managers to appear in the output and click OK. And now you'll see that my output has been narrowed to just those managers. Now this is one scenario where the outline layout of a pivot table can be a little bit more intuitive than this compact layout. So if I remove my filters here, and then go to Design, Report Layout, and then change my layout to be outline form, now we can apply filters to each of the fields in our rows area a little bit more intuitively. Instead of there being one filter button whose context changes depending on which level of the hierarchy you've selected in the first column, instead I have 3 filter buttons, one for each field in our rows area. So this is in fact one advantage of the outline view versus the compact view. Now this sort of filtering is fine, but it has a couple of limitations. One is that it's not terribly intuitive for a non-technical user of Excel to apply. And one of the great advantages of pivot tables is that they can be deployed as a kind of end-user tool that allows somebody without a lot of technical acumen to still quickly gain insights into their data. So to place a burden on those end users of understanding all the nuances of how to apply filters at different levels of groupings in our pivot table just doesn't make a ton of sense. And there's another problem. What if we want to filter our pivot table by a field that doesn't actually exist in the pivot table? Clearly we need another solution. So first I'm going to revert our layout back to the standard compact layout. And now let's look at a pivot table feature that allows us to filter the pivot table by fields that we haven't even included in the pivot table. These kinds of filters are called report level filters. So let's say, for example, we wanted to be able to filter this pivot table by call type. But we don't want to further clutter our pivot table layout by adding the call type field to our columns area or our rows area. The solution then is to add it as a report level filter. So to do that, I'll click anywhere inside my pivot, then go to our Pivot Table Analyze tab, and then hit my Field List button to make the field list appear. And now I'll search my field list for call type description, and then drag that down into the Filters area of the Pivot Table field list. And now you can see, above and to the left of my pivot table, there's a filter button corresponding to my call type description field. And then if I click that button, we have all the distinct values in that field. And if I choose any one of these, now all of my numbers are adjusted accordingly. So this grand total for my Aurora, Colorado site reflects the totals just for all tech support calls taken at that site versus all calls. And we're not limited to applying filters for a single value. If I click my filter button again, and then check this box next to select multiple items, now I can select any combination of the values available to me in that filter. So if I want to see all billing and sales calls but no tech support, I can just check those and click OK. And now my numbers will adjust accordingly. And just to prove to ourselves that this is working the way we hope, I'll go back to my raw data worksheet and then filter for site equals Aurora, Colorado. And then I'll filter for call type description is billing or sales. And you'll see in the status bar that 16,854 records were returned. And then if I go back to my pivot table, that's exactly the number we have reflected for Aurora, Colorado with those filters applied. Now keep in mind the advantage in terms of the layout of our pivot table to adding call type description as a filter versus including it in the actual physical pivot table layout. So if I clear the filter on call type description and then drag it from the filters area over to the columns area, we can still get to the same information, but as we saw in this layout previously, it's just kind of confusing. It's kind of busy. Now an end user of the pivot table is going to struggle to interpret what any given number here actually means in terms of all the different layers of filtering that are being applied. So if you find that you've dragged so many fields into the rows and columns area of your pivot that it's kind of hard to reason about the numbers, it might be time to pull one or more of those fields out of your main pivot table layout and convert them to filters instead. So I'll make my field list reappear and then go ahead and move call type description back to my filters area. And now to further demonstrate the trade-off between filters versus row and column groups, I'll move our site field here, which is currently the highest level in our rows hierarchy, to the filters area. So first I'll find it in my field list and then just drag it up under call type description in my filters. So the obvious advantage is that my primary pivot table layout is already a good bit cleaner and easier to reason about. Now the disadvantage is I don't get to see the numbers for each of my 3 sites side by side. Instead, I essentially have to page through those numbers one at a time by selecting those individual sites in my filter. But again, keep in mind that this trade-off can be more than worthwhile, especially if you want to add a large number of fields to your pivot table to slice and dice your data in different ways. While Excel will technically allow you to add as many fields to the rows and columns areas as you want, in practicality, excessively complicated layouts quickly become very difficult to interpret and reason about. But with filters, you can really add as many as you like without unduly cluttering your pivot table output. Now, one note about the types of fields that are most appropriate to use as filters. Filters work best on fields that have relatively few distinct values. So for example, our call type field, which has 3 distinct values, and our site field, which also has 3 distinct values, are good candidates to use as report level filters. But something like the date on which a call was made is probably not a good use case for a filter because there's so many possible distinct values. So instead of us seeing a list of 3 items when we click this filter button, we'd see a list of maybe hundreds or maybe even thousands of different distinct items. A field like that with so many distinct values makes more sense in the rows area of the pivot table versus as a filter. Alright, so we've already seen how filters can make our pivot tables more dynamic and user-friendly, while also keeping our layouts relatively uncluttered. But there's actually an even more powerful feature for filtering pivot tables, and that's slicers. We'll talk all about them in the next video. I'll see you then. Hey, welcome back. So we've seen how report level filters can make pivot tables more dynamic data analysis tools for our end users, while also giving us the flexibility to add more dimensions to our pivot than we could feasibly fit into the rows and columns areas. However, Excel gives us an even more powerful and flexible filtering tool called slicers, which can help turn your pivot tables into a dynamic reporting system. Let's see how. So my first step here is going to be to add slicers to our example pivot table on the same fields that we currently have added as report level filters. So I've already clicked inside my pivot table, so I have my Pivot Table Analyze contextual tab on the ribbon. And on this tab, I'm going to want to click the Insert Slicer button. So if I click that, now we see a list of all the fields available to us from our source dataset. So I want to add slicers for the same two fields that we currently have report level filters for. So that will be call type description and site. And now I'll click OK. And we see that instead of a couple of conventional looking filter buttons, we actually get these little boxes that just popped up in the middle of our worksheet. And as you might suspect, we can actually click and drag these boxes to reposition them wherever we want. So right off the bat, we have more visual flexibility than we did with report level filters, which are always in the same position relative to the overall pivot table. So now I'll just reposition our slicers a little more logically above and to the right of our pivot. Now actually using slicers is pretty daggone intuitive. You'll note that we already had our report level filter for site set to Jacksonville, Florida. And you see on our site slicer that Jacksonville, Florida is highlighted and our other two sites are not. This reflects that a filter is currently being set on Jacksonville, Florida. But if I click another site value in the slicer, and now not only does our data change, and not only is Aurora, Colorado now highlighted in our slicer, but we can see that the value in our report level filter changed to align with our slicer. So our slicers essentially can control what we see in those report level filters. Which begs the question, why would we need slicers and report level filters? And the answer is, you really just don't. So I'll actually go ahead and remove our report level filters by going to my field list and then just removing both of my report level filters. Because now our slicers give us all that functionality in a much more attractive, visually intuitive package. Now, just like with any other filter, you can filter for one item at a time, like we've already seen, or you can filter for multiple items at once. So if we click this little icon with multiple check marks above the items in our slicer, this will enable the multi-select mode of the slicer, which means instead of just being able to select one item at a time, we'll be able to select multiple. So now if I click Jacksonville, Florida, that will unselect it, while the other two items remain selected. And similarly, on my call type description slicer, I can click any number of items to unselect them and then simply click them again to select them. So I have the same filtering flexibility I had before, but a much more intuitive visual interface to communicate to the user of the pivot table exactly what filters are being applied and are not. Recall that with a report level filter, if multiple items are selected, you can't actually see which ones are selected unless you click the filter. So if I actually add one of our fields back as a report filter, let's say call type description, and now if I select multiple items in that field, you'll see that our report level filter just says multiple items, but my call type description slicer clearly highlights the two items that have been selected. Now, aside from making our filter selections more obvious and intuitive, slicers also give us a lot of flexibility in terms of how to style them. For example, we can resize them. So if I select a slicer, I can hover my cursor over any of these dots around the perimeter of the slicer and then just drag in any direction to resize the slicer however I want. So I'll actually do that to both of them. I can also change the caption that appears above each slicer. For example, this call type description caption seems a little too technical and not quite user-friendly enough for a pivot table that might be used by somebody who's not particularly technical. So to change that, after selecting the slicer, I'll simply click this contextual menu that pops up on the ribbon only when you select a slicer. We see that at the very top right of the ribbon. So if I click that contextual ribbon tab, over on the left side of that tab, you'll see a box for slicer caption. So I'll change call type description to just call type. And that already looks a lot better. Also on the slicer tab of the ribbon, we have a number of built-in pre-configured styles that Excel provides us for slicers. So if I click this down arrow to the right of those styles, I could choose any one of them to apply to our slicer. This works just the same as with the built-in styles for Excel tables or pivot tables. But for now, I'll revert back to the default light style. And lastly, to clear whatever filters we've applied via our slicers, we can simply click the funnel with the little red X on it at the top right of each slicer. Now, aside from simply being more visually intuitive and attractive, slicers have another really important advantage versus report filters in a pivot table. So we've already discussed that in reality, you're really limited to a certain number of row or column groups in your pivots due to concerns about readability. The solution is often to create multiple pivot tables that present different views of your data. One problem with this solution is that if you have filters on each of your pivot tables, setting that filter to a certain value on one pivot table won't affect the data in the other. And this can lead to your two views of your data being out of sync, which is obviously a bad experience for an end user. But slicers allow you to solve that problem by using one slicer to control multiple pivot tables. So let's see how. So let's say, for example, we want to create a second view of our data in which we group the data on our row labels by date instead of by employee hierarchy. So instead of rebuilding this pivot table from scratch, I'm actually just going to copy and paste it, which is a great way to save time when you're building variations of the same pivot table. The important thing to remember when copying and pasting a pivot table is that you need to copy all the cells that are part of that pivot table. If you miss part of the pivot table, you'll just copy the values from the pivot, but not the pivot itself. So once again, I'll go ahead and remove my report level filter. And then, starting with the top left cell in my pivot, I'll scroll down until I've selected the entire pivot, and then hit Control-C to copy. And then a couple columns over, I'll hit Control-V to paste. And then just to get our pivots aligned and below our slicers, I'll again copy the very first pivot, and now hit Control-X to cut, and then select cell A10 and Control-V to paste. So now we essentially have two identical pivot tables. But what we're going to do is change the row groupings in one to be dates instead of employee hierarchies. So I'll actually do that in our first pivot table. So back to my field list, I'll remove manager name and employee name, and then I'll add our call timestamp. And for this demonstration, I'll stick with Excel's default recommendation of grouping our data by month and then by day. But to get a clearer view of the detailed data, I'll right-click one of my month groupings, hover over Expand and Collapse, and then choose Expand Entire Field. So now I'll see my individual day breakouts under my month breakouts. So just a little more cleanup before we put our slicers to work. I actually don't think I need two columns between our pivots, so I'll delete one of those columns. And now I'll drag our slicers to be somewhat central above our two pivots. So now we're ready to see the power of controlling multiple pivot tables with different views of our data with a single slicer. So if, for example, I select a call type of billing, you'll see the numbers in both of our pivot tables decrease accordingly. So now I have two completely distinct views of our data, both of which can be controlled with multiple levels of filtering by one set of slicers. Now keep in mind that we were able to connect these slicers to both pivot tables without any additional steps because the second pivot table was copied from the first. Now if we had created a brand new pivot table from the same data set but not copied it from the original, we'd have had to take one extra step to connect our slicers to that second pivot table. So if I select one of our slicers, and then again select that slicer tab on the ribbon, and then hit the Report Connections button, you'll see a list of the pivot tables our slicers are connected to. In this case, just the two pivot tables we have here. But if I had created a third pivot table from our data set from scratch, not by copying and pasting one of the existing pivot tables, that pivot table would appear in this list, but unchecked. But all we'd have to do is just check the box next to it, and then we could control that pivot with these slicers as well. So I hope you can see what a powerful feature this is. Using slicers to control multiple pivot tables that provide different views of your data are the key to creating dashboards with a number of at-a-glance views that can be controlled by a single filter. Okay, so our pivot tables have grown fairly sophisticated. But one thing that's remained fairly simple is the actual calculations we're doing in our pivot tables. To this point, pretty much simple counts, sums, and averages. Up next, we'll look at some techniques for adding more sophisticated calculations to our pivot tables. I'll see you then. Hey, welcome back. So while we've been able to assemble some pretty nifty breakouts of our call center data using pivot tables, our actual calculations themselves have been pretty basic. Just counts, sums, and averages of numeric fields in our data. And to be sure, pivot tables aren't quite as flexible when it comes to crunching out complicated calculations as formulas and functions. However, there are a few tricks we can use to add some more nuanced metrics to our pivot table views. One such metric we might want to add is service level percentage, which is the percent of customer calls that were answered within an acceptable time frame, say 30 seconds. So if we look at the detailed data on our data worksheet, we'll see that we have a column called wait time, which tells us how long a customer had to wait before their call was answered. But how the heck can we translate this into a percentage of calls answered in 30 seconds that would appear in our pivot table? Well, one common approach in scenarios like this is to add a helper column or helper field to our detailed data that we can then use in our pivot to calculate the metric. So first I'm going to insert a new column to our table to the right of wait time. And I'm going to call this column service level met. And now in the column, I'm going to write an if statement that looks at our value in the wait time field. And if that wait time is 30 seconds or less, we'll return a 1, indicating that service level was met. And if not, we'll return a 0, indicating that it wasn't. So let's go ahead and type that out. Okay, so this is a step in the right direction, but how can we use this field in our pivot table to produce the percentage that we're looking for? Well, first let's try to drag it into our pivot table. So back to the worksheet that has our pivot table, I'll go to our field list, and then I'll look for our new field. But that's weird, I actually don't see our new field. Now why is that? So our new field is not appearing in our pivot table field list because our pivot table isn't actually directly tied to our source data in real time. Instead, when we created the pivot table, the source data was loaded into something called the pivot cache. This pivot cache is basically a copy of the data that the pivot table points to. Now what this means is that if we make changes to our pivot table's source data, the pivot doesn't update automatically, unlike with formulas and functions. So to see our new field, here under our Pivot Table Analyze tab, I'm going to want to click the down arrow under this Refresh button, and then choose Refresh. And now if we scroll up our field list, we see our service level met field. So now I'll drag that into our values area. And then just to clean up our pivot table a little bit, I think I'll go ahead and remove these other metrics. So already this is providing us with some level of useful insight, which is basically a sum of all the calls that were answered at each site and by each manager and each employee respectively within that service level threshold we defined. But what we're looking for is a percentage. So how can we turn those ones and zeros into an actual percentage that will be reflected in our pivot? Well, it turns out it's actually really easy. All we actually have to do is summarize those ones and zeros as an average instead of a sum, and then format the result as a percentage. So if I do all that and click OK, and then once more, now we have the percentage of calls that were taken within 30 seconds at each level of hierarchy in our pivot table. Now it might not be completely intuitive as to how this works, so I'll take a second to explain the math behind it. Let's say you have 10 calls and 9 of them were taken within 30 seconds and 1 was not. That means 9 of those calls would have gotten a 1 in our new service level met field and 1 did not. So what happens when you take the average of 9 ones and 1 0? Well, if you add the 9 ones up, you get the number 9. Now, to get your average, you take the sum of those numbers and divide by the total count of the numbers, which is 10. So 9 divided by 10 is 0.9. Then if you format that as a percent, you get 90%. And that's exactly how our percentages here are being calculated. If 88.18% of a certain subset of records had ones instead of zeros, that's the percentage we see in the pivot table. Generally speaking, whenever you have some kind of binary performance metric like this one, where some threshold of performance was either met or it wasn't, and you want to calculate the percentage of times it was or wasn't met in your pivot table, then this approach is an extremely effective one. And then just for some final cleanup, I'll go ahead and rename our new metric. And there we go. Now there is another feature called calculated fields, which allow us to bake these derived fields directly into our pivot table. But to be honest with you, they don't offer nearly the same flexibility for doing calculations as derived fields in our source data. And they're also a little bit clunky to work with. If you want to add derived calculations directly into your pivot tables, there's a much better way to do it than calculated fields, but that involves a relatively new feature in Excel called Power Pivot and a whole new formula language called DAX. Now that's a whole other topic in and of itself that's a lot more than we can go into here. It's honestly a topic worthy of its own course. So for now, I'd recommend the approach of adding calculated fields to your detailed data and then summarizing them creatively in your pivot table. Now, one other way to put a different spin on the counts and totals in your pivot tables are to summarize them as percentages rather than straight numbers. So let me show you what I mean. If we drag our call ID field back into our pivot and then summarize it as a count, and then I'll just name it calls answered. Now we have a breakout of the number of calls answered at every level of hierarchy in our pivot. But what if I wanted to show these values as a percent of a whole? Well, Excel actually makes this really easy. So if I right-click any value in that column and then hover over Show Values As, one popular option we can choose is percent of column total. Now that makes sense in this particular situation because we have our metrics oriented in columns and not rows. If our metrics were oriented towards rows and our categorical fields like site and manager were oriented by columns, we'd instead choose percent of row total. But if I click this percent of column total, now the number next to each individual row label reflects that particular item's contribution to the overall total. So for example, Aurora, Colorado took 34.34% of all calls taken at all 3 of our sites. Jacksonville, Florida took 35.93%, Spokane, Washington took 29.73%, and then if we go all the way down to our grand total, it adds up to 100%. And we see similar breakouts for individual managers. So Jamar Prall's team here took 11% of our overall call volume. And then that breakdown continues to the level of the individual employee. Now another approach we can take, if we right-click any number in this column again and hover over Show Values As, is to display our numbers not as a percent of the overall total, but as a percent of the total of the parent group. So if I choose percent of parent row total, now we see some more meaningful numbers at the lower levels of hierarchy in our pivot. For example, instead of seeing tiny percentages next to each individual employee, which while accurate, don't give us a picture of how these employees are doing relative to their peers, we now instead see the number of calls each employee took as a percentage of the calls taken by their team. So if I highlight all these percentages under LC Taplin and then look down at the status bar, you'll see they add up to 100%. That's because under this mode of summarization, individual numbers are shown as a percentage of the total in the parent group. Likewise, if we added the percentages of Elsie Taplin, Nova Harshberger, Rana Taub, and Shayla Lyon, they would add up to 100%. That 100% being the number of calls taken at the Aurora, Colorado site. Either of these approaches can be valid depending on your particular use case. So that's it on pivot tables for now, but we have one more incredibly important Excel feature to cover: macros, which give us the power to automate repetitive tasks with ease. That's up next. I'll see you then. Hey, welcome back. So our purchase history here is actually a pretty rich data set. We have over 2 years worth of purchases broken out by date in a number of different categories. But the very thing that makes the data set so useful, its sheer size and scope, also makes it difficult to make sense of. Good luck getting anything meaningful out of just scrolling around on this worksheet. Now, we were able to create a chart that visualized our spending habits by category, but to go any deeper than that, we'll need help from a pivot table. As we've seen, pivot tables can help us make sense of large data sets like the one we have here fast. So what I'd like you to do in this iteration of the course project is create a pivot table on a new worksheet of your project file that summarizes our purchase history just like you see here. So as you can see, on rows we have the transaction description and category, while on columns we are grouping by year, then by month. Note here that while we don't have specific year and month columns in our data, you don't actually need those. As long as we have a column with dates, we can group them however we want in the pivot without actually adding new columns to the raw data. Then of course, we also have a report level filter on category group. Now I also froze panes at the top left of the pivot table data to make it easier to identify what we're looking at as we scroll across different years and months and different transaction descriptions and categories. Now, as usual, feel free to format this pivot to your liking and add any additional bells and whistles you think would add value. So pause the video and take a shot at building this out. You'll find my walkthrough right after this. Okay, I hope you had fun with that. So now it's time for me to walk you through my solution. So first I'll switch over to our starter file. And then my first step will be to create a new worksheet right before our transaction history sheet here that I'll call spending summary, which is where we'll put our pivot table. So I'll first insert my new worksheet and then name it spending summary. And now I'll insert a new pivot up in cell B3. So I'll hit Insert, Pivot Table, and then for the source data, I'll select the entire table on my transaction history worksheet, and then click OK. And now that we have our source data defined, we just need to drag these different fields into the various parts of the pivot table to get that layout we're going for. So first I'll drag debit down in values, and then I'll go ahead and format that as currency. Next, I'll add purchase date on columns, and then drilling into one of these years, we see that we have quarter as a next level grouping, which we don't really want. So Excel, in trying to be helpful, added this by default when we added a date field to the columns area. But fortunately, we can customize the levels of grouping that are applied to dates without needing to add custom fields to our raw data set. So all we have to do is with any of these years in my pivot table columns selected, I'll right click and then choose Group. And here you see that by default, Excel wants to group our dates by years, quarters, and months. But all we want is years and months, so I'll just unselect quarters and then click OK. And now we have the column grouping we're looking for. So next we'll turn our attention to the rows area. So first I'll drag in category, and then description under that, and that's looking pretty good as well. So then the last piece of our basic structuring will just be to grab this category group field and add it to the filters area. So now we have that as a report level filter for our pivot. So we're done adding fields to our pivot table for now, so I'll go ahead and close out of our field list. And now we can turn our attention to the appearance of our pivot table. So first I'll go to our Design tab, and then just scroll through some of these canned predefined pivot table styles until I see one I like. I think I like this one typically, and that already looks much better. Now I also think I'll insert one row above the pivot table just to create a little buffer between the pivot table and the boundary of the grid. And I'll also make our first column, column A, just a bit narrower. And then to make it easier to navigate our pivot table, I'll select this top left cell in our pivot table data, and then go to View and Freeze Panes. And that way, if I scroll down, my column headers are still visible, and if I scroll to the right, my row headers are still visible. And then to make our layout a bit more compact, I'll collapse groups for both columns and rows. So I'll select any year, and then right-click, and then choose Expand Collapse, Collapse Entire Field, and I'll do the same with our category grouping on rows. And then finally, just to make the whole worksheet look a little bit cleaner, I'll also remove grid lines. And at this point, our pivot table looks to be complete. So I can apply filters with my report level filter. I can drill down into subcategories, both on rows and columns. And I can even drill down into any of these numbers you see here to get the detailed data behind them. All right, that's it for this phase of the course project, but we'll have one more layer of enhancements to add after the next section. I'll see you in the next video. Hey, welcome back. So in this one, we're going to start our exploration of Excel macros. So a macro is an Excel feature that allows you to record a series of actions you take in a spreadsheet and then play them back, so to speak, any number of times. Kind of like how you can record yourself on video and then play that video over and over again. Now, macros are terrific for automating repetitive, monotonous tasks. If you've ever had to apply the same set of formatting steps on the same Excel spreadsheet day in and day out, macros can definitely come to your rescue and save valuable time out of your day. So let's dive right in and see how to record a macro in Excel. So the first step to recording a macro is to make sure that you can see the Developer tab on the Excel ribbon. If you can't, you'll need to go into your Excel options to make that tab visible. So it's not visible on my ribbon currently, so to make it visible, I'm going to click my File tab, and then at the bottom of the list of options on the left, I'll click More, and then Options. And now on the dialog box that pops up, I'll click the Customize Ribbon tab, and then in the list of tabs on the right side of this page, I'll find where the Developer tab is listed, and make sure that the box next to it is checked. And then click OK. And now you can see that the Developer tab is visible on my ribbon. So if you look to the left side of this Developer tab, you'll see a section called Code, which has all the buttons and commands relevant to creating and using macros. So to begin recording a macro, as you might have guessed, you simply have to click this button called Record Macro. Now for our first macro, we're not going to do anything revolutionary. I'm just going to type out a standard Hello World message. So let's go ahead and do that and see how this works. So I'll click my Record Macro button, and now we're prompted to specify a name for our macro. And this is just how we'll identify the set of steps we're going to record so we can play them back later. Now, all we're going to do is type a simple Hello World message, so we'll simply call our macro Hello World. Now you can see that we also have the option to assign a keyboard shortcut to our macro, and also store our macro in another workbook besides this one. But most of the time, you won't need these options, so we'll just focus on entering the macro name. So now if I click OK, any action I take in the Excel spreadsheet from now on is being recorded by Excel. Now this is to allow the actions I'm taking to be played back in the same order whenever I run the macro in the future. So my first action will be to just type Hello World, my name is Travis in cell A1. And now, because the text of that sentence was wider than column A, I'm also going to autofit column A. And finally, I'll reselect cell A1. And now the series of steps that I wanted to record for future playback is done, so I want to stop recording my macro. And if you look back to the code section of the developer tab of the ribbon, you can actually see that my record macro button has changed into a stop recording button. So if we want to stop recording our steps, all we have to do is just hit stop recording. Now the next step obviously is to play our macro back. So before we do that, to prove to you that the macro works, I'm going to go ahead and delete column A, just so you can see the macro do its job. And now to play the macro back, we just hit this macros button and look for our macro in whatever list of macros appears. Now we've only recorded one macro in the spreadsheet, so we just see the one macro that we just recorded. So to play our steps back, with that macro name selected, we just click the Run button on this dialog box. And there we have it. The macro replayed the steps that I took, and you'll note that it took Excel a lot less time to perform those tasks than it did me, because it's performing them at computer speed. Once Excel knows what I want to type, it can type it a lot faster than me, and that's not just because I'm a bad typist. Now you may have noticed that directly beneath our Record Macro button, there's another button called Use Relative References. Now if you're wondering what that does, it basically allows you to record the steps in your macro, not in terms of absolute locations on your spreadsheet, but relative to whatever cell you had selected when you started recording the macro. So if you record a macro using relative references, the macro will actually execute different steps depending on whatever cell you had selected before you play the macro. Now I would caution that the vast majority of the time, you're using a macro to perform the exact same set of steps every single time. That's kind of what they do best. They automate repetitive, redundant tasks that stay the same day over day. All that is to say, I would caution you against using that relative references button, and if you ever find that your macros behave oddly, check to make sure that this Use Relative References button has not been accidentally clicked. So if you click it, it will stay slightly darkened, so that way you can know that any macros you're recording will be recorded using relative references. So again, if you find that your macros are behaving a little wonky, make sure that Use Relative References button is unchecked. Alright, so with that said, it's time for us to go ahead and save our Excel workbook that contains our macro. So let's go to File and Save As to save our workbook. And we can name our file Hello World. But what I want you to pay attention to is the file type that is listed by default. And that is an Excel macro-enabled workbook with an extension of .xlsm. So this is an important point. Excel does not allow you to save macros in a standard Excel workbook that has the .xlsx extension. In fact, if you try, and I will try by choosing the standard Excel workbook extension, and then hit Save, Excel throws up a warning message. It says, the following features cannot be saved in macro-free workbooks, a VB project. So you might be asking, what does a VB project have to do with macros? Behind the scenes, Excel is recording the steps you take when you record your macro as code. And then when you play the macro back, it's simply executing that code. And that code happens to be a language called Visual Basic, or VB. The bottom line is, though, Excel will not allow you to save a workbook with a macro using the standard file extension. So we'll click No here, and then we will choose our recommended macro-enabled workbook extension and click Save. So our last step then is to see if there are any hiccups when it comes to reopening a macro-enabled Excel workbook. So let's close out of this file, and now we'll try to reopen it by using File, Open, and now we can see that our Hello World workbook is under our most recently opened file, so we'll go ahead and click that. And now we see a security warning directly beneath our Excel ribbon. It says macros have been disabled. So what's up with that? Well, it turns out that there have been several cases in the past of hackers using that VB code inside of an Excel macro to introduce a computer virus to someone's computer using the Excel spreadsheet as a kind of Trojan horse. As a result, by default, Excel disables macros and forces you to explicitly say that you want to enable the macro before you'll allow it to be played. Now, obviously, we created this macro, so we don't have any concerns about security, so we can click Enable Content. But this does point out that you should exercise a degree of caution when enabling macros in a spreadsheet that was sent to you by somebody that you're not familiar with or do not trust. But for now, let's go ahead and click Enable Content. And now we can delete our first column again, and then go back to our Developer tab, find our macro, and hit Run, and it works just like before. Okay, so that's probably enough on macros for one video. But up next, we'll take a quick look at an alternative, and I would argue much niftier way to run macros in an Excel spreadsheet. I'll see you then. Hey, welcome back. So in this one, we're going to take a very brief and I hope somewhat fun detour from all this hardcore practical stuff to explore an alternative way to run our macros that's a little more convenient, definitely way cooler, and might just impress your boss or anyone else who uses your spreadsheet. So here we have the same spreadsheet where we left off in the last video, which has the single macro we recorded that simply enters a hello world message in a cell of our spreadsheet. But to run this macro, we first have to make sure the Developer tab of our ribbon is selected. Then we have to hit the Macros button on that tab. Then we have to select our macro in whatever list of macros is there, and finally hit Run. A bit of a clunky process, and certainly not one well suited to an end user of our spreadsheet who's not terribly familiar with Excel. Fortunately, Excel provides us with an alternative mechanism for running macros, which is to run them with a button that we insert into the spreadsheet. Not only is this more convenient and intuitive and user-friendly, it also looks pretty darn cool and kind of makes us feel like bona fide application developers. Or at least it made me feel that way the first time I used a button to run a macro. So to do this, first make sure you're on that Developer tab of the ribbon, and then click this Insert button in the Controls section of that ribbon. Now clicking this button will reveal a list of various types of controls you can add to your spreadsheet. The only one we need to worry about is this one at the very top left, which if you hover over it, you'll see as a button. So let's just click that. And now if we hover anywhere over our grid, you'll see the cursor has turned into a tiny little cross. This indicates that you can draw a figure directly onto the Excel spreadsheet simply by holding down your mouse button and dragging down and to the right. So let's do that. So I'll click and hold my mouse button, and then drag down and to the right, and I see a rectangle forming, which will ultimately be the outline of my button. So when I get this outline to be about the size I want my button to be, I'll simply let go of the mouse button, and now Excel automatically guesses that I want to assign a macro to this button, which means that whenever I click the button, that particular macro will be executed. Now obviously we want to run our Hello World macro with this button, so I'll select that one, and then click OK. And there we have it, a button that can run our macro. But you'll note that the button is outlined in these little white circles. That means that the button is in edit mode. So if I were to click the button now, nothing happens. But the button being in edit mode is actually a good thing, because we certainly don't want to stick with that very generic button 1 caption on the button. Instead, if we just click anywhere inside the text, now you can see that our cursor is flashing, indicating that we can edit this text like we could text in any other part of Excel. So I'll delete all this text, and then just type Hello World. And finally, to take our button out of edit mode so that we can run our macro by clicking it, all I have to do is click anywhere outside the button. So I'll click up here in cell A1, and now the moment we've been waiting for, if I simply click our button, yay! You see that our macro executed flawlessly. So again, This is not a game-changing modification to our process, but it definitely has a little cool factor to it. It saves a couple steps, and it's certainly more intuitive for an end user of our spreadsheet who might not be as comfortable as we are navigating all of the dense menus of Microsoft Excel. Now lastly, note that if you're not satisfied with the location or size of the button after you've created it and you want to edit the button, all you have to do is right-click the button and then left-click anywhere inside the button to get rid of this menu. And now you're able to resize the button, edit the text, or if you want to move the button altogether, hover anywhere inside the button until you see the cursor turn into these two crossed arrows. And then you can just hold down your mouse button and then drag the button anywhere you like to relocate it. Alright, up next we're going to get back into the serious stuff and demonstrate recording a slightly more involved and practical macro, and also delve into how to edit a macro once you've recorded it. I'll see you then. Welcome back. So sometimes when we're recording macros, we might make a mistake. After all, we're human. And because Excel is dutifully recording every single action you take in the spreadsheet as you're recording the macro, that mistake will be baked right into your macro. So if you've gone to the trouble of recording a complicated macro that captures a large number of steps, and you made one single mistake in the course of recording that macro, you could delete the macro and start over, but that's a lot of work. It's way more efficient to edit your macros. The caveat being, it does require you to tinker with a little bit of programming code. But this is not as bad as you think. It turns out that every macro is actually defined by programming code in a real programming language. Excel writes this code as you record the macro. And then when you play the macro back, this code that Excel wrote is executed. That's really what's happening when you play the macro. Hence, the key to editing the macro is editing the code. So take, for example, a scenario in which we are emailed a file every day that is somewhat poorly formatted and requires some transformation and sprucing up before we can present it to our boss. For example, here we have these merged cells in the first row that we don't need. Also, our employee ID column in column B really isn't crucial to any decisions that our boss might make, so we don't need that. Several of the columns aren't wide enough to accommodate the data in them, and so on and so on. The bottom line is we need to take some steps to clean this data up, but these steps will look the same every single time we process a file. So we can choose between hoping we remember all the different things we need to do to transform the data every time we get this file, or we can record a macro to do all that stuff for us. I think you can probably guess at this point which approach we're going to take. So without further ado, let's go ahead and record a macro to clean this data up. So I'll go to my Developer tab, and then hit Record Macro, and I'll call my macro Data Cleanup. And once I click OK, we can begin cleaning up our data set. So my first step will be to delete this first row that we really don't need at all. It's just merged cells that serve as kind of parent column headers to the actual column headers in our data. So I'll go ahead and delete that. And next I'll delete that employee ID column that we don't need. And now I'll highlight my column headers and then hit Control B to bold them. And then finally, I'll select the entire grid by clicking above and to the left of the grid, and then double-click in between any two column headers to auto-fit my columns. Okay, at this point, I think my data set's where I need it to be, so I can go ahead and stop recording my macro. But now that I look at my data, I realize that I made a mistake. Instead of deleting my employee ID column, it looks like I accidentally deleted my site column. So this is darned inconvenient. At this point, it may seem that my only recourse is to delete my macro and then re-record it and hope that I don't make any mistakes this time. But fortunately, it turns out there's an alternative. And that is actually going into the macro code and simply changing the one step of the macro where I made a mistake. So how do we do that? Well, first we'll click the Macros button on the Developer tab to bring up our macro. And then with our Data Cleanup macro selected, instead of clicking Run, we'll click Edit. Okay, so here's that scary code that I talked about earlier. Doesn't look so bad, right? Well, this macro, like all other macros, is written in a programming language called VBA, which stands for Visual Basic for Applications. VBA is actually part of a larger family of Visual Basic languages, the main difference being that it's specialized for automating Office applications like Excel. So VBA can be used to manipulate and automate almost any aspect of Excel, from rows and columns to formulas, charts, and pivot tables. Now, it's also a full-blown programming language, much like Python, for example, that gives you all the constructs of a programming language, like if statements, loops, and functions. Now, don't worry if those terms aren't familiar to you. It's often even used for complex financial and scientific applications. But don't worry, most of the time, most people just use it to automate menial tasks in Excel, and VBA is awesome at that. And the best part is, we really don't even need to understand VBA syntax very well to edit or even enhance our macros. Just some common sense and a willingness to make a mistake here or there. So with that said, I'm going to maximize this code window, and I'm going to ask you to take a few seconds to just scan this code and using plain old common sense, try to identify the line or lines where you think I went astray when I deleted the wrong column while I was recording my macro. So pause the video, look at this code, and when you feel like you've got a pretty solid guess as to what line or lines of code are relevant to the mistake that I made and the mistake I'm trying to correct, hit play and we'll get busy editing this code. Okay, so hopefully you were able to figure that out. You'll see here that in this fourth line of code, I'm selecting an entire column. And then in the very next line, I am deleting my selection. Now, while this syntax might seem a little odd with things being separated by dots and some slightly strange keywords, in my opinion, Excel gives you enough hints to figure out what you need to change. So it looks like we deleted column C. Now, if we go back to our data, which we can do because this Visual Basic window is actually an entirely separate window from our Excel spreadsheet, I can go back to my Excel spreadsheet by clicking View and then Microsoft Excel, and now I'm back in my worksheet. So looking at how our columns are aligned, it appears that instead of deleting column C, I should have deleted column B, where our employee IDs are stored. So with that said, let's go back to our VBA editor, which I can do by going to my Developer tab, and then just hitting this Visual Basic button. And now I'm right back where I was. So all we're going to do is just change this line where we select all of column C to select all of column B instead. That's simple. Now, one more thing I want to point out before we put this edited macro to the test, and that is that because Excel is recording every single thing that you do while you're recording the macro, sometimes there are unnecessary extraneous steps built into the macro that just don't need to be there. For example, if you look at this third line, active window.small scroll down equals -9. Now you don't need to know exactly what that means, but the word scroll should be a clue. What that means is, at some point during the recording process, I must have scrolled down, and Excel dutifully captured that movement. But that isn't something that I need to be part of this macro. So I can just go ahead and delete this line, and that will have the effect of making my macro run a little bit faster and a little bit cleaner. So with those changes made, let's close out of our VBA editor. And now to put our edited macro to the test, I'm actually going to delete all of our data here. And then I'm going to paste in another sample data set with the same structure as the one we used to record our macro to see if our edited macro gets the job done. So that's over in another workbook. So I'll just copy this and then paste it right into our first cell. And without further ado, let's go ahead and play our macro. So I'll go to Macros, make sure our data cleanup macro is selected, and then hit Run. And look at that. Without having to re-record our macro, our employee ID column got deleted, while our site column has now been retained. and all the other steps appear to have executed flawlessly as well. So editing macros won't always be this smooth, but just understand that it's no big deal if you make a mistake while you're editing that VBA code, because you can always go back and change it, or at the very worst, just re-record the macro. Over time, editing and studying VBA code generated by macros can actually teach you a decent amount of VBA. And eventually, you can even learn to combine snippets of code from different macros you've recorded in creative ways. All right, now that we've seen a fairly straightforward example of how to record and edit an Excel macro, let's walk through a real-world case study of how a macro can be used to automate the generation of a report. That's up next. I'll see you then. Welcome back. So now that we've covered the basics of recording and editing macros, let's walk through a more realistic example of using macros to generate a report automatically. So here we have an example of an employee productivity report for a call center. On our main tab, we have a pivot table with call center employee statistics, and then a slicer that can be used to manipulate that pivot table. We also have the current date here in cell B1 being generated dynamically by a today function. Now this pivot table in turn points to data on this data worksheet. This data worksheet actually contains a table that has an external data connection to a CSV file. So to get the most up-to-date data for the report, we actually need to refresh the data connection between this table and that CSV file. Now the raw data in the CSV file doesn't have all the data points we need to generate a meaningful report. For example, the raw data contains employee IDs, but it doesn't contain employee names or the sites where employees work, their managers, and so on. To account for that, our report template also has additional worksheets containing tables with this type of lookup information that we subsequently VLOOKUP back into our main data table. So on our employees worksheet, for each employee ID, we have the employee's name, their site, and their manager name. Similarly, on our call types worksheet, for each call type code, we have the description of that particular call type. So then if we go back to our data worksheet and look at these last several columns, we see that instead of them being sourced from the raw data, they instead come from those lookup tables that are housed in separate worksheets of this spreadsheet. So to generate a report from this template, our first step is to refresh the data connection to the external CSV file in this table. Once that's complete, we can then refresh our pivot table, which points to that table. Now, one interesting point about pivot tables is that once you have refreshed the pivot table against its source data, even if you delete that source data, the pivot table remains intact. That's because, unless the pivot table is actively being refreshed, it actually points to a highly compressed copy of the source data called the pivot cache. So by deleting our source data and just leaving the pivot table, we can make our file much smaller and more streamlined. And then if an end user wants to get back to any of this detailed data, all they have to do is double-click any of the numbers in the pivot table. Finally, after we've done all that, we will also want to copy and then paste special values over our today function in cell B1 so that the value in that cell always reflects the date on which the report was created. Then we will save the file as a standard non-macro enabled file to a separate folder. That's the folder where the end users can pick up and use our report. It's important whenever possible to save any file that will be used by a non-technical end user in the standard .xlsx format rather than as a macro-enabled spreadsheet. A non-technical end user might be confused by the security messages they would see as a result of opening a macro-enabled file, so if it's possible to save a macro-enabled template as a standard Excel file before it's used by an end user, that's ideal. So the bottom line is we have a series of repetitive steps that we need to follow in the same order every day to produce this report. Sounds like an ideal candidate for a macro. So with that, let's go ahead and dive right in and record our macro. So I'll go to my Developer tab, and then hit Record Macro, and I'll name the macro Generate Report, and click OK to start recording. And again, my first step is to go to my data worksheet, and then under Table Design, I'll hit the down arrow under the Refresh button, and then click Refresh, and this will refresh that connection to my external data source, which is that CSV file. And then once that's done, I'll go back to my Summary tab, click anywhere inside the pivot, go to my Pivot Table Analyze tab on my ribbon, and then again click that down arrow under Refresh, and now I'll refresh the pivot table, which is pointing to the table that we just refreshed a moment ago. Now once the pivot table is refreshed, I don't need my data worksheet anymore, so I can delete that. Likewise, with my data worksheet gone, I don't need either of my lookup tables, so I can delete both of my worksheets that just contain a lookup table. Then I need to copy and paste special as values over my date value in cell B1 so it always reflects the date the report was created. So I'll right click, copy, paste special values, and then I'll hit escape to take us out of copy mode. Now finally, I will save this file as a non-macro enabled file, in other words, a standard Excel file. So I'll go to File, Save As, and then I will save it under my Report subfolder. And for the name, I'll just get rid of my template suffix here, and click Save. Now Excel's telling me that I cannot save my VB project, which is basically my generated VBA code, in a macro-free workbook. But we do want to save this file as a macro-free workbook, so we're going to go ahead and click Yes. Now at this point, we've followed all the steps we need to follow, so we can go to our Developer tab and then hit Stop Recording. You might be wondering, and you would have good reason to do so, how we will still be able to work with our VBA code if our Excel file has been saved in a format that doesn't allow for macros. Well, the good news is that the VBA window is actually a separate window from our Excel window. So we can still get to our VBA code. We just can't save that VBA code as part of this particular Excel file. So what we'll need to do, since we saved our template as a completely different Excel file, we'll need to reopen our template and then drop that VBA code in there. So first, I'm going to reopen my template. And now I need to grab the VBA code that was generated when I recorded the macro and make sure that it's added to a macro in this Excel file, not the report file that's meant for an end user. So I'll go to my Developer tab, and then Macros, and you can see that the macro we generated is listed, but that Excel prefaces the name of that macro with the name of our other open file. So that's Excel's way of saying, this macro is available for you to look at, but it's not part of the file that you are currently looking at. So let's click Edit to see that code. And now before we dig into what's going on with this code, I'm actually just going to copy it by highlighting and then hitting Control-C. And then I'm going to close my VBA editor window. And now that we're back in our template, the next question is, where am I going to put this code that I have just copied to my clipboard? Well, one easy way to find a home for this code is to just record another macro in this file. And then as long as we don't save this file to a non-macro enabled file, that second macro we've recorded will live in this file, and then we can copy and paste our code right in there. So I'll click Record Macro. And again, I'll call this macro Generate Report. And click OK. So now I'll click Stop Recording. And then to get to our new macro, I'll hit the Macros button. And now you see that we have two Generate Report macros available, but one is prefaced by the name of an Excel file. Now again, that's your tip that that particular macro is part of another open Excel spreadsheet, but not the one that we're currently looking at. So when we look at this second one that does not have the name of a file in front of it, that tells us that that macro is part of this current workbook that we're looking at. So that's the one we want. So we'll click Edit, And you see that by recording a macro and then really not doing anything before we stop recording, you pretty much just generate an empty macro. But we have all the code we need from the other macro we recorded, so I'll just hit Control A and then delete to get rid of this code, and then Control V to paste in our code from our other macro. So now I'll close out of the VBA editor window, and then to make sure that I'll always be able to use this macro in this template file, I'm going to save this file as a macro-enabled file. So I'll go to File, Save As, and I'll keep the name, but I'll change the extension from the standard .xlsx to a .xlsm, a macro-enabled workbook, and then hit Save. So before we run our macro to test it, let's go back into the code to see if there are any tweaks or enhancements we can make. So again, I'll hit my macros button, and then open up our Generate Report macro. Now overall, this code looks like it's doing what we need it to do. And while I know I told you I wasn't going to get too deep into the weeds of VBA programming, I am going to cheat just a little bit and show you just 2 tricks, just 2 lines of code that can help you out a lot as you're editing your macros. Now the first line I'm going to put ahead of all of our other macro generated code, and that is going to be application dot display alerts equals false. So what this does is ensure that as you're running the macro, you don't have to interact with and dismiss all these dialog boxes that are going to pop up as the macro does things like deleting sheets or saving a file as a different format. In the same way that these types of actions will generate dialog boxes that you have to dismiss when you do them just in the course of regular business in Excel, they'll generate these same dialog boxes when you run the macro, unless you use this line of code before the rest of the code in your macro. But by using this line, application.displayAlerts equals false, you're going to suppress all of those dialog boxes, which is typically what you want when you're trying to run a smooth, quick, automated process. And then the other tweak we'll make is to add a message box at the very end of our process. This really isn't necessary, it's more of a cool feature, but just like assigning a macro to a button, it kind of makes us feel more like programmers. So after my last line here, I'll type message box, and then a pair of parentheses, and then in the message box, I'll type a pair of quotes, and then inside those quotes I'll say process complete. And all this is going to do is when all of the other steps in the macro have been taken, a little dialog box is going to pop up and confirm that all is well and all the steps were completed successfully. So let's close out of this and then save our template one more time just to capture those changes. And then just to confirm that this is actually working, I'm going to close the report file we just created a moment ago and delete it. So I'll go back to that file and close it. And then I'll go to where that report is saved in the file system and hit delete. So now if we run our macro and there is a file in that location, we'll know that it worked. Now we've put a lot of work into this thus far, so it's time to put it to the test. Let's hit our macros button and then hit run to see what happens. Nice. And we get a friendly message telling us the process is complete, which we can dismiss just by clicking OK. Now our pivot table has been generated. All of our secondary worksheets have been deleted. Instead of a formula here in cell B1, we just have the date value. And then if we go back to the folder where we had formerly deleted this report on the file system, there it is, freshly generated. So it looks like our macro worked great. But before we go, I think I'd like to add one more feature to our template that generates this report. And that's a button to run the macro. So I'll go back and reopen my template file. And then hit Enable Content. And now, as we saw a couple videos ago, I'll just add a button to run our macro. So on my Developer tab, I'll click the down arrow under my Insert button, and then choose Button, and then just drag down and to the right to create the outline of my button. And then I'll assign that to my generate report macro and click OK. And then I'll just edit the caption of the button to say generate report. Now the one problem with this is we don't want the end user to see this button on their finished report. The finished report won't even be a macro enabled file, so this button won't really be able to do anything. Its only purpose is in the template file that creates the end user's report. So at this point, we need to update our macro to delete this button at some point during the macro's execution. Now we've already gone through quite a few steps to record this macro, so we definitely don't want to re-record the entire macro just to add this one additional step. Now what would be great is if we knew what line or lines of code we need to add to our macro just to delete this button. But unless we're VBA experts, we won't know that. But the awesome thing about macros is we can let Excel teach us VBA by recording the macro to do whatever task it is that we're trying to add to our overall process. So if I want to capture the VBA code to delete this button, all I have to do is record a second macro, then delete the button while that macro is recording, then just grab that code and drop it into my main macro. So let's do that. I'll hit record macro, and this macro is temporary so it doesn't matter what we name it, so I'll click OK. And now I'll right-click the button to select it without actually executing the macro it's tied to, and then just hit delete. And that's all we needed to do, so I'll hit stop recording. But before we move on, one crucial step we don't want to lose sight of is the fact that we still need our button. So I'm actually going to hit Control-Z to bring our button back. Otherwise, we would have defeated the entire point of this exercise because we wouldn't even have our button anymore. Now it's worth noting that hitting Control-Z to undo the deletion of the button won't have any impact on the macro code at all. Once we hit stop recording on the macro, that code that captured whatever actions we took while recording the macro was set in stone. So let's go to our macros, and then take a peek at the code in our macro3 macro that we just recorded. And there we have it. 2 lines of code that do exactly what we want. So I'll just copy these guys, and then go back into my code for my generate report macro. And now I can just add these 2 lines wherever I want within the macro. And since we only use the button at the very beginning of the process to trigger the macro, I'll place it right beneath our application.displayalerts line. So now I'll close out of my VBA editor window, and then save our file one more time to capture those most recent changes. And one more time, to prove that our macro is working like we think, I'm going to close that report that was generated the last time we ran the macro, and then delete that file from the file system. So first I'll close this file, and then I'll go back to where that report was generated on the file system and delete it. And then I'll go back to our template file. And now for the main event, drumroll please, I will click our generate report button. And there's our friendly little message. And if we click OK, we see that the button we used to generate the report is now gone. And all the other steps were executed as well. And then if we look back to the same location on the file system where we had just deleted the report, now it's back, but the modified date is 9 minutes later. So at this point, I'd say we can be pretty confident that our macro is working exactly as intended. Now, one thing I can't overemphasize here is that there is a huge difference between recording and editing macros and truly understanding and writing VBA code from scratch. That is a completely different endeavor that's honestly worthy of its own course. My goal here is not to teach you to be a skilled VBA programmer. My goal instead is to teach you how to learn more as time goes on, by recording macros to perform different tasks, studying the code that Excel generates, and possibly combining snippets of code like that in creative ways. Over time, you'll be surprised at how comfortable you can become with VBA and how much you can do with it without ever having a deep knowledge of computer programming. My hope at this point is that you at least know enough about macros and VBA to be dangerous. You do not have to be an expert VBA programmer to be an absolute rock star around the office. If you just know enough to automate redundant processes that are eating away minutes or hours of your colleagues' days, you can absolutely be an Excel hero. All right, I hope you really enjoyed that section on VBA and macros. Again, if you're really serious about becoming a VBA programmer, this is just the first step in a very long journey, but I think it's a great start. Happy coding, and I'll see you in the next one. Hey, welcome back. So as well structured as our transaction data here is, we often aren't so lucky when it comes to real-world data. And as we've seen over the last section, Excel macros can help us automate the process of cleaning up messy, real-world data by executing the same steps we would, but with the speed and reliability of a computer, and not a person just clicking around with a mouse. So here we have our transactions data in its original form, as it comes when it's exported from our bank's website as a monthly report. Now, as you can see, all the stuff we need is there, but there's also a column, transaction ID, that we don't need. The formatting is off for the purchase date and debit amount, and there's also a couple of columns that are out of order. Now, since this is how the data is always structured in its original form, we'll always need to apply the same series of transformations to it to make it usable for our budget and expense tracker spreadsheet. Sounds like a job for a macro, right? Right. So what I want you to do for this, the very last iteration of the course project, is record a macro that cleans up this data so that it matches the structure of the data on the transaction history tab of our budget and expense tracker workbook. Now first, I'd recommend creating a new worksheet to paste the raw data into. Then, record a macro that takes the following steps. First, delete the transaction ID column. Then, move the category column to the left of the debit column. Then format the date column as, well, date. And finally, format the debit column as currency. Once you've finished recording your macro, test it out by deleting the processed data from the workbook, pasting the raw data back in, and then running the macro. Lastly, I'd suggest going into the generated VBA code behind the macro to make any necessary edits or clean up any extraneous code. Well, at this point, I'll get out of your way so you can get to it. So go ahead and pause the video and take a shot at creating this macro, and I'll be here with a walkthrough whenever you're ready. Okay, hopefully you had fun with that. So now I'll go ahead and record the macro in my version of the budget and expense tracker workbook. So first I'll go into that workbook and then create a new worksheet that I'll call raw data. And then into that worksheet, I'll copy and paste our raw data extract. So now that I've got the data in our workbook, we're ready to begin recording our macro. So I'll go to my Developer tab, and then hit Record Macro, and I'll name my macro Clean Data, and then I'll just hit OK to begin recording the macro. So my first step will be to delete this transaction ID column, and then I'll select this entire category column, right-click and cut, and then select the debit column, right-click, and then insert to move that category column to the left of the debit column. Next, I'll select the entire date column and format as date. Then I'll select the debit column and format as currency. And then finally, just as a kind of bonus step, I'll go ahead and click above and to the left of the grid to select the entire grid, and then double-click between any two columns to auto-fit column widths. Then I'll select cell A1, and at this point, I think I'm done recording. So I'll hit Stop Recording. And at this point, I could definitely go ahead and test the macro, but as a best practice, I always like to take a peek into the generated VBA code just to see if there's anything that looks awry. So to do that, I'll hit Macros, and then Edit My Clean Data macro, and just scanning the lines of generated code, everything looks sensible except for this one line that says active window dot small scroll down equals -6. So at some point I must have done some scrolling inadvertently, and of course that was captured by the macro recorder, but I don't need that step to be replayed every time I run the macro, so I'll go ahead and delete that line of code. And otherwise this code looks good, so I'll close out of the VBA editor. And now to test my macro, I'll just delete this data, and then go back into my raw data and copy it once again, and then paste it into cell A1. And now let's go ahead and run our macro and see what happens. And look at that. All of our transformation steps were applied more or less instantaneously. And now that we have a system in place for automatically processing that export we get every month from our bank's website, we can actually just tack this data on to the end of our transaction history table. So below the column headers, I can select the top row and then hit Control-Shift down to select the rest of the data, and then Control-C to copy. And then I'll go over to my transaction history table, and then Control down arrow to get to the bottom of the table. And then I'll just paste in below the last row of data. And because this data is structured as an Excel table, Excel is smart enough to incorporate those new rows that we pasted in as part of the table, and it's also smart enough to automatically populate our VLOOKUP formula in the last column. Okay, so that's it for the course project for now. And while I won't be providing you any more guidance on different features you can add, I say that's it for now because with the foundation of skills you've developed in this course, you're more than qualified to customize this budget and expense tracker in whatever way you need to make it work for your unique situation. So I really hope you've enjoyed following along and building this project as much as I have, and I'm super confident you'll be able to use this as a jumping off point to build all sorts of interesting projects in Excel, whether it's at work or just to make your life more efficient. Keep learning, and I'll see you next time.
Hey there. I wanted to take a second at the end of it all, at the end of your learning journey, to just say this one thing, and that is thank you. I know your time is valuable. We have limited time on this earth, and you decided to spend your time and your money, frankly, with us, doing something that takes a long time to learn. So truly, from the bottom of our hearts, I know it sounds cheesy, but thank you for dedicating your time and effort to this course. I hope you got what you wanted out of it, and congratulate yourself for getting this far, because a lot of people start, a lot of people have hopes of learning, but they give up along the way. But you didn't do that. You worked through the challenges, the problems, and you got here. Now, your learning journey doesn't end here. It keeps going. But I hope this created a foundation for you to go off and learn things on your own, get a promotion, get hired, start a new business. Whatever it may be, again, thank you and best of luck with your learning journey. This is just the beginning of whatever you decide to do in the future. So thank you and good luck.